theme, input of the initial data. So let's start subsystem Asonika-Tm and carry out input of a printed unit from subsystem pcat project import pcat projects. So let's choose the file plata PDF. So we see converting of the data from pcat system into the subsystem Asonika-Tm. As a result, automatically we receive allocation of the radio elements around the printed circuit board on the plane. So the initial data is taken from the Asonika-Tm database automatically. So here is the result, the image of the board. So after that, let's enter the material of the board. So let's enter the database and choose the material of the board. Material number 51 with thickness 1.5. And we will receive 2D and 3D image of the board. We need to fix the board with the screws at 4 corners. So we will choose diameter of the screw 5 millimeters. Add 1 screw. Move it to the corner and add 3 more screws and allocate them to the corners. So 2 other screws. So as the result, we have the board screwed by 4 screws at every corner. Now let's enter thermal boundary conditions. So we choose natural convection in an environment and radiation from the flat non-developed surface. A next structural element. So for the first side of the board, we choose ambient temperature of 20 degrees, which is received from the subsystem Asonika-T. Let's input temperature of the adjacent structural element, which will be equal to 40 degrees, and air pressure of 760. Similarly, we enter boundary conditions from the second side of the board. So after that, let's set mechanical effects. So they are received from subsystem Asonika-M as per the result of simulation of the block in which the board is allocated. So let's set harmonic oscillation. Input range of frequencies from 2 Hz to 2000 Hz. Specular acceleration density, and let's input the effect point by point. So next, random oscillation. We input range of frequencies from 2 to 2000 Hz. Let's then enter spectral acceleration density, 1000 squared G on Hertz. And then we set point by point. The next effect, single shock. So duration, range of time, shock influence up to 5 milliseconds. So we set peak shock acceleration to 40G, and also we set interval of attenuation to 20 milliseconds. So the pulse is a triangle form, so we set triangle impulse. The next effect, multiple shock. We input duration of the pulse, 1 millisecond. So the impulse has a triangle form. We set peak shock acceleration to 40G. Then amount of shocks, 14. And a step between impulses to 20 milliseconds. And interval of attenuation to 200 milliseconds. And then we set triangle impulse, point by point. The next effect is the linear acceleration. So we set 100G and duration of 100 milliseconds. And we set it point by point, linear acceleration. And the last effect we put will be acoustic noise. For the acoustic noise, we input range of frequencies from 10 to 10,000 Hz and a pressure of 175 decibel. And then we input the diagram of acoustic noise point by point. So we have set all the effects for the board. So now we shall specify the checkpoint, that is the place of mounting the acceleration sensor. So we need to enter the capacity of the thermal emission for ready elements. So for the element DA1, we input 1000 milliwatt, the capacity of the thermal emission. And for the diode VD2 to VD6, we put 400 milliwatt. So let's save the project.